Okay, so the test, here's how the test is gonna go, first of all. So tomorrow, let's put all the phones and everything away, please. So tomorrow, you're gonna go, you're gonna go to one, I'll put the labs up at the end here, where you're gonna go. Let's get rid of that. So, you'll be there 8 a.m. through noon, I think, testing. Tomorrow, you're going to take the multiple choice part, which is, we're gonna go through the other part today, but the other stuff we've been reviewing, kind of that style stuff. I think there are 40 questions, but maybe less than that, maybe less than that. You will most likely finish that without too much trouble tomorrow, but do take your time, right? Then, here's what I'm gonna do with my group, what I'm assuming everybody else will do also. I'm gonna recommend to all the others that they do this too. You have the option that first day then of going on and doing the second part. If you're really feeling like, man, this is a piece of cake, I just want to do this, I mean, then that's fine. But otherwise, if you're feeling like that's been a lot of math, which it will have been, and you want to give your brain a break, then just save that for the next day, right? Nothing's going to be going on in any of your classes that's going to be a big deal. You're not, there is officially, by the way, just so you know, you cannot be held responsible for anything that happens while you're gone, right? So they're going to either make accommodations or more than likely, it's gonna be so many people gone, I mean, it's gonna be all the juniors, and so more than likely, nothing's going on in my classes the next couple of days, for example. I don't think there will be in probably any class that you're in, so that part's not a big deal. What I do recommend you do though, even if you've decided that you're not gonna do the performance task tomorrow, this is what the brain science says you should do. I just finished reading a book about this. So you should probably open up the performance task and just read through it, take a look at it. Here's why. The way the brain works, it's really interesting. You don't have aha moments or kind of moments of inspiration or genius when you're thinking about it. It almost never happens. It almost never happens that you're going to sit down to solve a problem and you have some huge breakthrough. What happens, far more likely, what happens most of the time, is your brain, when it relaxes and it goes away from the task, that's when things happen, right? That's when your brain latches onto a solution. You've probably had that experience before. You're thinking about something really hard, and can't remember this name, or then you go away and do something else, oh, it's just like that. You're least expecting, right? Kind of all of a sudden you have it. So you want to probably at least open up the performance task and read through it so your brain can process it, right, that night. Even while you're sleeping, your brain will unconsciously, it'll kind of work on that problem for you. So, but don't feel like you have to do that tomorrow, like you have to go through and do both parts. If you want to take a break, by all means, do it. All right, so let's look at a couple of performance tasks. Here's one, right? So I want to go through, we'll talk about kind of how to do this, but more important than how to do it, it's going to be kind of how do you answer the questions in a way where you're going to get full credit, right? Because the math on the performance tasks is never going to be super hard math. It's going to be pretty reasonable. A lot of the math may even come from like lower grade level standards, but what they're wanting you to be able to do is take the math and articulate it in a way where somebody else could understand what you did, right? So what about this one? Your friend Abby is making a movie. She's filming a fancy dinner scene and she has 2 types of candles on the table. She wants to determine how long the candles will last. She takes a picture, lights the candles, and then lets them burn for 1 hour. She then takes a second picture. You can assume that each candle burns at its own constant rate. Okay, so here's the first picture, here's the second picture, but more importantly, they give you some data, right? Some numbers that you can use. This is 0 hours, this is after 1 hour. So they tell us, candle type A, initial height. That's kind of an important word, right? What's initial height mean? Starting height. Okay, so the initial height is 20 centimeters. Candle type B, initial height, 10 centimeters. Candle type A, height after burning for 1 hour is 16 centimeters, right? What's that telling us, by the way?
It went down.
Okay, so what could we maybe call that? It's going down, it's burning down by 4 centimeters in an hour. Rate of change. Okay, so the rate of change, or you might call it the burn rate or something like that, right? The rate of change is going to be -4, isn't it? It decreased by 4 after 1 hour, right? Candle type B, after burning 1 hour, it's 9 centimeters. So what's the burn rate for candle B? -1. Good. It's dropping by 1. That's the minus part, right? It's decreasing by 1 every hour. Okay, so you use this information to help Abby think about the candles she might use for the film. All right, so the first part, all they're really wanting you to do for the first part is answer a question. Candles A and B are lit at the same time. What will be the height in centimeters of each candle after 3 hours of burning? Well, what's it going to be?
12 and 3.
What's it going to be? 12 and
3.
It's going to be, hang on, is that right? Then what might help here, what might help would be to make a table, right? I either make, I mean, this is just, all they're asking you to do is put in the answers. But on your scratch paper, I would strongly recommend that you make something like a table, right? Where you're going to do, for candle A, you're going to do height, and B, height, something like that, right? And this is going to be time in this column, so you got 0, 1, 2, 3, 4, something like that, right? All the way down. So what's the initial height for A? 20. For B, it was 10, right? And we could do like centimeters. I mean, this is for your benefit anyway. So after 1, it was 16. This was 9. What's this going to be after 2? 12, and then
8.
and then if we go all the way down to 5, what's it going to be? 0. So this would just be 9, 8, 7, 6, 5, right? Does that make sense? So after 3, it would be 8 and 7. Okay. So that's all they want for this are the answers. Candle type A is 8 centimeters, and candle type B is 7 centimeters. Make sense? Okay. So let's look at how they grade that. Okay, by the way, this is the document. I just pulled this up off Moodle. You can look at this tonight if you want, right? If you haven't already. So 1 point's 1 or nothing on this one. All or nothing, 1 point. The student provides both correct answers. Candle type A will be 8 centimeters and candle type B will be at 7 centimeters. That's it. Any other answer is worth nothing. Okay, you gotta get them both right.
Do you have to say centimeters on it?
I would, because those are the units. Yeah, okay. Yeah, I think you should. Okay, what about part 2? Here's part 2. Just ignore that table. That's not a big deal. The candles of each type were lit at the same time. Abby thinks that since candle type A burns more quickly than candle type B, that it will burn out, have a height of 0 first. Julie thinks that since candle type B starts out much shorter than candle type A, it will burn out first. So here's what they want you to do, and read the directions carefully. You want to know everything they're asking you. So there's a couple parts to this. They say, first of all, which candle will burn out first? Well, that's just going to be a direct answer, right? And we know it's going to be candle A, right, from our table. Give a mathematical explanation to convince Abby and Julie of your solution. Clearly identify the quantities involved, okay? So what would our mathematical solution maybe look like? What could it be? We kind of already did it, but we'd have to just do it within the question now. Could be the table. Yeah, that's great. I mean, the table works, right? The table it's a mathematical organization of what the height's going to be after each hour. Now, when you're inputting these, I don't know exactly what tools are going to be available, but it's not like you have to spend 9 hours making a beautiful table. You could just explain what's in the table. You could just say for something like for candle type A, here are the heights for each hour it's been burning. You could say like time t equals 0, or initially height's 20. After 1 hour it's 16. After 2 hours it's 12 centimeters, etc. Just list them all out. That's fine. For candle type B, just do the same thing. Just list what the heights would be. I mean, and it's not like that's the only way to do it, but you get the idea. You're getting out all the information there, and so then you could say something like, okay, so the answer is that A is going to burn out first, right? And the reason it's going to burn out first is because although its initial height was 20, but the burn rate, it burned 4 centimeters every second, right? So you're mentioning both important parts there. Each one of them latched onto one of them. Abby said it was all based on the burn rate. Julie thought it was all based on the initial height. It's a combination of both. See what I'm saying? So what answer, let's look at some sample answers. See what would get 2 points. 2 points, the student correctly determines that candle type A will burn out first and provides a valid mathematical explanation that includes the initial heights and the burn rates. One point would be you maybe get the right answer, but you didn't have a good enough mathematical connection. So here's actually some sample answers. Here's a good one. Abby is correct. I don't know why there's a couple little typos here. There shouldn't be the quotation marks don't mean anything. That's not important. Abby is correct because candle A looks taller, but it burns at a rate of 4 centimeters per hour, where candle B looks shorter, but it burns at a rate of 1 centimeter per hour. Since candle A is 10 centimeters tall, it will burn out in 5 hours, where candle B would take 10 hours. Okay, why is that considered to be correct? That's correct because this student correctly identified that candle type A would burn out first and used both the initial heights and the burn rates. Because remember, they wanted you to identify any important quantities. Well, what are the important quantities? Initial height, and you can say rate of change or burn rate or whatever you want to call it, right? This one actually looks pretty good, but it's only half credit. Candle A will burn out first because candle A burns 4 centimeters each hour, while candle B burns 1 centimeter each hour. Candle A will burn out while candle B still has 5 centimeters left. That's pretty good, but what did they not do? What did they not mention?
Candle A's actual height.
Well, I mean, yeah, but even then, that wouldn't have been quite enough. What did they not mention? The initial heights, yeah, right. All they mentioned were the burn rates, or the rate of change. They didn't mention the initial heights. You gotta mention all the important quantities, right? So once again, I mean, what's the moral of the story? Writing more, including more information is gonna be better, right? You might include too much, but they're not gonna penalize you for having too much in there. They're just gonna penalize you for having too little, right? And then by the same token, I mean, this looks not too bad. Honestly, this looks pretty good, but they just didn't quite get everything in there. Candle A will burn out faster because it gets 4 inches shorter every hour, when B only gets 1 inch shorter. So one way you could think about this, and I think those are supposed to be centimeters, not inches, but you know, once again, no typo. Here's how you can kind of think about this. Here's what I've always told people on these kinds of tests. Imagine that you're trying to explain this to your younger sister or brother, you know, if you have one, or if it's not, to one of your younger cousins or something. Somebody that's younger than you that doesn't necessarily understand all the implied math. I mean, yeah, it makes sense that, you know, we can kind of, when you're talking amongst yourselves, you can probably think, well, it's pretty obvious it starts at 20 and 10, so we just need to mention how much, but it's not obvious to somebody who's younger than you, right? So you got to mention everything, okay? Questions? Okay, what about the next part? Abby has 3 hours left to film. She lights a new candle type A and candle type B and then starts filming. In the 3 hours she has left, will Abby capture the moment when the candles are exactly the same height? So that's a yes/no question, but then also explain to Abby, so think somebody younger, how you can determine the answer, right? So what are you gonna do? We already made that table, right? Are they, after 3 hours, wasn't candle A 8 and candle B was 7? So candle A was still taller, wasn't it? So we hadn't seen when they're the same height yet. So the answer is no, right? How would you connect that though? Probably just with the table, right? Table would be fine. But make sure you're explaining what it means. Here's an example of what looks pretty good, but there just isn't quite enough connection. For 2 points, you have to correctly say no, they're not going to capture. She's not going to capture the moment when they're the same height, and support it with mathematically valid argument. It doesn't have to be like solving a system of linear equations. It could. I mean, that's fine. You could make an equation for candle A, for the height of candle A as a function of t, and you could make an equation for candle B where the height is a function of t and set them equal to each other and solve the system. That's fine. You can do that, but you don't really need to. You just have to make, like a table, to me, would be the most direct and easy way to do it. So look at this example right here. They don't even show a 2-point question. This one looks pretty good, but it's only 1 out of 2. Look what they did here. They put some thought into this. I mean, they said 1 times -4 is this, 2 times negative. So this is telling how far that first candle's decreased, right? And so it's literally, this first row is after 1 hour, after 2 hours, after 3 hours, there's candle A and there's candle B, right? And so their statement is, no, Abby will not see the 2 candles at the same height during the 3 hours that she is filming. What did they probably not do there? They include what? Yeah, they gave us all the right numbers and equations, but there's no connection between the equations and their conclusion, right? Once again, imagine that you're explaining this to somebody younger than you. They're not going to look at that and understand that, right? You got to be able to explain, what does that mean? And the explanation can be simple. All you needed to do was just say, after 1 hour, candle A has a height of 16 and show the equation. After 2 hours, 12, 3 hours, 8, etc. Same thing for B, and then there it is, right? There's the connection to, to the math, right? Okay, so what they say, this response is almost a 2. In order to move from a score of 1 to 2, the student would need to be more explicit about the meaning of the numbers and calculations, and ultimately connect those to the context, right? Okay, that's it. Just don't get penalized for not writing enough, for implying stuff, or assuming that the person that's grading this is going to connect those. They probably are smart enough. It's probably a math teacher, but that's not the point. They want you to justify the answer with an explanation. Okay. Okay, and this, once again, this looks pretty good. No, because at 3 hours, candle A is 8 centimeters and candle B is 7 hours, she would only be able to, she was filming for 4 hours. Okay, that's great, that's true. Obviously, they knew what they were talking about, but they didn't provide a mathematically valid argument. The table would have, pushed that one over the edge. Would have made it a 2. Okay, last two, I guess. You've decided to use functions to help Abby think about the candles. You show her how to represent the height of a candle H as a function of time T using this equation. H equals K plus NT, right? So you're, once again, now reread that. So you're coming up with a function H as a function of T. So what are the variables? Height and time, right? H and T are the variables, right? H is the output, T is the input, right? First, all they want you to do here is first explain to Abby what K and N represent in order to model the different candles. Be specific in your explanation. So what are you going to say? What's K? What's K going to be? If this is how we're going to do for candle A and for candle B, the height equals K plus N times T, where T is number of hours and H is height. What is K? What would the number for K be for part A? 20. What would the number for N be? -4, right? Okay, so that's not what they're asking though. They just want to know, what was your thinking there? What do K and N represent? What's K?
20.
Starting height or initial height, whatever you want to call it, right? Start value, initial value, start height, initial height. It's all the, you get the idea. What's N? Say it again. Burn rate. Yeah, it's going to be the rate, isn't it? Because it's what's being multiplied by T. It's like the slope. Think if you go clear back to Algebra 1, when you guys were first talking about modeling linear equations, wasn't a linear equation always an initial value plus a rate times X or T or whatever the input is, right? So this is just going to be the rate of change or the burn rate, right? And if you want to go further, you could say for candle A, K is 20, and and N is -4, and for candle B, K is 10, and N is -1. So you can say that stuff. But the main thing you got to say is that K represents the initial height and N represents the burn rate. And if you get both of those, it's 2 points. If you only identify one of those, it's 1 point. Otherwise, it's 0. Okay? Make sense? Questions? Okay. Then finally, the last part is actually pretty simple. The last part, all they want you to do is choose either candle A or candle B and create an equation that will tell Abby the height of the candle at T hours. So we already essentially did that, right? We just are going to plug in K and N. So we could say for candle A, H equals 20 minus 4T, or 20 plus -4T, right? That's all they're looking for, is you just to input an equation there. Okay? Does that make sense? Not a big deal. Really, that's not, that's, if you got 4 hours to do that, or more if you need it, that's really, you can do that stuff. You really can.
So the second half of the whole test is just one problem with multiple steps?
It's, okay, my understanding is, it's going to be, it could be like one long one or 2 short ones. Okay? But probably, I would assume it's going to be one like this. Okay? Let's see. So, how about, real quick, there's where you go. Just make a note of that real quick while it's up there. This is where you're going to go first period tomorrow. That's supposed to say, that's a C. That's supposed to be a C, Google typo.
Poor Austin.
Yeah. That's supposed to be Krieger. There you go. Okay. Okay, make sense?
Have your first initial on. It doesn't even have an A in front of it.
Miss Joy.
So, where's, I'm looking at that, but they've got them kind of out of order. Yeah, so you would be, right, you'd be in 209. Yeah. Does that make sense? So, I mean, it's like they're saying, like, why is there's only one Gillette, but there's a bunch of different Johnsons. If you're like Bobby Johnson, then you're gonna be there, but if you're Zach Johnson, then you're gonna be, Bobby Johnson's there, but Zach Johnson's there. See what I'm saying? Based on your first initial. Okay. Yes, ma'am.
So, I already passed this last year.
This is different.
Okay.
This is different.
Okay.
Yeah. Are you?
Yeah.
Yeah. You don't have to do this.
Okay.
You want to try going to the library? You
Yeah.
can if you want. That's fine. Yeah.
So on the second day, is it just like the problem we just did?
Say it again.
On the second day, the length of it, it's gonna be like what we just did or longer?
About like that, I think. I mean, it's. I seriously think probably the performance task is only going to take you. It might take you an hour. It's probably not going to take you 4 hours. I mean, that's if you're really careful and you write everything out, right? I mean, you could do it in 5 minutes, but you got to be really careful about it. But yeah.
I'm not gonna be here on Wednesday, so they're just gonna find me.
Okay, so yeah, they'll just find you. That's right. Your music. So, I mean, you'll have the option if you want to, you can do them both tomorrow, but don't feel pressure to do that. You really, I mean, if you feel like it's in your best interest, you're just not feeling it, like, man, I need a break, this is too much math. Then open it up and look at it and think about it for the rest of the period maybe, but then don't do it if you don't want it. They'll get you.
But if I miss, like, obviously I'm gonna miss class on Monday then to do it.
Doesn't matter, doesn't make any difference. Just miss class. This is more important than after you go to class. Promise you. Yes. Great.
Do we have to like sit right next to the person who's like out there in class, or can we just?
I don't know. You'll just be able to see it. Yeah, in my opinion. Okay, listen please, listen. I'm gonna push with all my might for that, and I think it'll be fine. I don't think anybody's gonna push back to it. I mean, maybe they might say, maybe they'll say something like, okay, well, it can only be a C, but I am gonna say, well, but I wanna at least be able to, like, if you had a C and you do well on this, I wanna also say that it bumps you up a grade. That's what I'm really gonna push for is, if you pass this, you've met a big national standard. I mean, why would we not? And this constitutes evidence for graduating. It's going to be used by colleges to decide admission. That's used like an SAT. So if you do well on this, why wouldn't it demonstrate that you know the level of math you need to know? But also, if you did well on it, I mean, I'll bump you up a grade too. Yeah. I don't think there'd be any problem. I can't promise it yet. I mean, I think it'll be fine. Yeah. Okay, so moving on here. There's one more I want to just briefly take a look at. We won't spend as much time on this one.
Wait, Miss Joya?
Yeah,
Are we taking it in the computer lab or in class?
computer lab. Yeah. Those labs that I had up here, right.
Oh.
Okay, so let's have a look, please. So here's another one. Let's just have a quick look at this. We'll just briefly go through this.
Wait, can I get this water?
Yes, you may. Okay, so this one, how much time we got?
10 minutes.
10 minutes, okay, so we'll be quick. But I want to give you one more sample of kind of some things you might see stuff like this. I think this is a little bit older one. I think the one you just saw is more likely to be like one that you'll see. But this has a couple little things I just want you to see on. So New York State wants to change its system for assigning speeding fines to drivers. The current system allows a judge to assign a fine that is within the ranges shown in Table 1. Right. So there's some pretty big ranges there. Some people have complained that the New York speeding fine system is not fair. It doesn't seem very fair. I mean, look at based on what the judge says, there could be a pretty major difference in what you're fined. New Drivers Association is recommending a new speeding fine system based on Massachusetts, blah, blah, blah. So here's what they're recommending. This is Massachusetts. Anything 1 to 10 miles per hour over the speed limit, there's a $100 flat charge. 11 or more, it would be a $100 flat charge plus $10 for each mile per hour over 10, right? Does that make sense? So if you went 11, it would be 110, 12 would be 120, etc. So they want you to analyze this and propose a fairer speeding system. Okay, so first thing is, here's what I kind of want you to see. Use the information in Table 2 to plot data points for Massachusetts speeding fines. Plot a point to represent the fine for driving 5 miles per hour over the speed limit, and then go in increments of 5 all the way up to 45. So this is using a tool on the test where you're gonna put dots on the graph, right? So it should look like this is 1 or nothing, and that's what it should look like for full credit. Okay. You got a dot at 5, that's 100, at 10, it's 100, and then after that, it goes up 10 miles per hour for each mile per hour over 10. So 15 would be an additional 50, 20 would be additional 100, etc. Right? So there's what they're looking for that part. Okay, part B, create an equation to calculate the Massachusetts speeding fine F based on the number of miles per hour M over the speed limit, when M is greater than or equal to 1 and less than or equal to 10. Okay, so from 1 to 10, what do we see up here? Well, from 1 to 10, it's just 100, right? So that's a pretty easy equation. F equals 100, right? That's it. F equals 100 is the right answer, okay? Okay, next part, now they're saying, okay, same question, but now for when M is greater than 10. So how could we do that? Let's go back and look at this for a second. When M is greater than 10, well, here's the line, right? And here's the description. Come on, right here. So 11 or more, $100 flat fee. So one way you could say this is you could say something like F equals 100 plus $10 for each additional mile per hour over 10. So how could you say that? If M stands for the number of miles per hour that you're speeding by, over the speed limit, how could you pick only the value, only the amount over 10? Well, using M though. Like, let's just think of a couple examples. If M was 12, what number am I going to multiply by 10? 2. If M was 13, I would multiply 3. So what am I doing? I'm taking the value of M, and what am I doing to find out what I multiply by 10? What if M was 15? 5 times 10. What am I doing? What am I doing to get the number that I'm multiplying by 10? I'm subtracting 10 from M, aren't I? Does that make sense? Okay, so that's one way you could do it. That's one way you could do it, is that way. But there's another way too, I think, that's just as good. You could also just look at, the graph that you made, right? Isn't this the part of the graph that you're interested in right here? This line right there. If I continue that line, where does it go? It goes through 0, right? So another way of saying that, for values greater than 10, I just want the equation of that line. Well, what's the equation of that line? F equals, what's the start value? What's the y-intercept, in other words? 0. So it's just 0 plus, and then the slope is 10, right? Plus 10 times M, because M is the number of miles per hour over the speed limit, right? So you wouldn't even write the 0. You could also just say F equals 10M, right? Because that's the equation of the line that you're using to pick those values, right? Either way would be fine. Okay, so now what? Let's see. Oops. Okay, so that puts us right there. So either we could do something like that, or we could do something like that, right? Or something that's equivalent. I mean, you could Take either one of those and, you could distribute the 10 if you want to. There's lots of ways you can do that. Okay, but I'll be right. Okay, here's the next part though. They want you, it says, boy, that's small. The graph below shows data from a sample of actual fines for driving above the speed limit in New York. Use the connect line tool to create a piecewise linear model with 2 line segments. One for M is between 1 and 20, and one for M is between 20 and 40 to approximate the best fit for the data. So this is stuff, you've done stuff like this before. This is where we're just going to draw a line segment that kind of goes through the center of the distribution. We're just going to eyeball it, right? And there's a lot of different answers they would accept. There's not like it's just one that works, but it's going to look something like that, isn't it? If we want to draw one that goes through that part of the distribution from 1 to 20, we're just going to draw a line that kind of goes right through the center of that, right? There's a wide range of answers they accept for that. What about the second part? Well, the second part is going to connect there, and it's going to go through the center of that distribution. Once again, wide range of answers they accept, okay? So then they want you, for the next part, they want you to write an equation, right? For part A, they want you to write an equation for the first part, from 1 to 20. So we'll just go up to this line segment, and we're just going to write an equation for that, right? We'll make a little slope triangle. So we'll just know, if I go, what's my rise between those two? If I kind of estimate the coordinates of those points, and what's my run? And so that's going to give me M. That's going to be the start value, isn't it? Right, so we'll just come up with, it's going to be different for everybody, and once again, there's a wide range of values they accept. Okay, so, what does that give us then? So they'll take anything like an equation with a slope ranging between 1 and 3. So you can have a factor of 3 difference in your slopes. That's huge. And a y-intercept ranging anywhere between 80 and 100 would have been fine, right? So everyone's going to maybe draw that slightly differently, but that's pretty wide variation. Okay, what about the second part? Same thing, right? They want you to write an equation of the line you get when m is greater than 20. So what could you do with that? Well, that's this line, right? So we could, once again, we could just make a slope triangle where there's our rise and there's our run based on the coordinates that I'm estimating for those 2 points, right? And then what about B for the start value? Well, we could do a couple things. Once we know what M is, we could go back and we've got, what's our equation going to look like? It's going to look like, kind of like, I'm just going to write it like we normally would. Y equals mx plus b, where m and b are the numbers I want to find, right? Instead of y and x, we're actually going to use f and m, right? But just to make this connect this to what we've done in the past, let's pretend it's y and x. So if I know what m is, if I use my slope triangle to find m, the only thing left I have to find is b. So how have we done that in the past, right? We just plug in values for x and y and solve for b. We could do that. That's fine. The other thing we could do if we want to is we could just say, well, let's just extrapolate this line backwards, right? If this is the rise over the run, well, that's going to be, I'm just going to continue to go down by whatever the rise was here, and that's going to be, the run is the same as 20 for both, right? Either way, it doesn't matter. I just need to know, either way, I need to know what's my approximate start value and what's the slope, right? And look at the answers now. If that sounds intimidating, it shouldn't be, because look at all the different answers they'll let you have. Your slope could be anywhere between 13 and 18, and they're going to give you the right answer. Your y-intercept could be anywhere between negative 260 and negative 120. That's a pretty big range of values, right? So you're going to get it. I mean, and then finally, the NDA claims that the proposed new model for the New York speeding fine system is fairer than the current system. Do you agree or disagree? And explain your reasoning using specific examples from the task, right? They tell you to use specific examples. So you'd have to say, yeah, I agree, but also something like, you know, there's a huge disparity. What would happen if you went 11 miles over and compare the two, right? You got it. You're fine. Look at this tonight for 5 minutes and you're good.